Hi, I'm Alexa von Tobel, and with me is Lex Gelman of Inspired Capital. And today we're excited to talk to you a little bit about our thesis around quantum computing.
So imagine a world where your data is more secure than ever before, where drug development takes a year instead of decades, where clean energy finally scales the way we need it to, and where financial systems can optimize thousands of variables at once.
That's what quantum computing unlocks, and the window to build in this space is happening right now. So first, in plain English, what's quantum computing? Well, quantum computing is not just a faster computer, it's a fundamentally different type of machine. Classical computers, every laptop, every server, every data center running AI today is working on ones and zeros. And quantum works on both simultaneously, which means that it can solve problems that are simply beyond what any classical computer can do today. Let me give you a concrete example. Let's think drug discovery. Today, simulating how molecules interact requires enormous computing power, and even then, classical computers can hit a wall. A quantum computer can simulate molecular behavior at a complexity that is simply out of reach today, that could compress decades of pharmaceutical research into simply a mere set of years. Quantum is perfect for those problems.
For years, the knock on quantum was great in theory, impossible in practice. Too noisy, too error-prone, too fragile. That's all started to change. Google's Willow chip crossed a threshold the field has been chasing for decades. They proved that adding more qubits actually reduces errors instead of amplifying them. That's the moment the entire field flipped. IBM is projecting verified quantum advantage by the end of 2026. Microsoft and Atom Computing are delivering the first error-corrected machines to research institutions this year. Leading researchers are now calling this quantum's transistor moment, the point where functional systems actually exist, and the challenge shifts to manufacturing and scale. We've gone from theoretical to real, and the pace of progress is accelerating faster than anyone expected.
So here's how we think about this a little bit at Inspired. We began our deep thesis work in quantum almost 2 years ago, and we have now spoken with dozens, nearly 100 experts across government, labs, academia, and the private sector. And our conclusion is the following. This is a hardware-led market. Value will consolidate around a number of companies capable of building truly scalable quantum systems. This made the founding team the most central question. We were looking for the rarest of rare talent. Think the top 0.1% quantum experts with a credible path to scalable hardware. That is what led us to one of our first quantum investments, Logiqal. Dr. Jeff Thompson is a Princeton professor and one of the world's leading researchers in the neutral atom quantum computing. His core innovation reduces the qubits needed for fault tolerance by 10 to 100 times, which is simply a generational leap. Jeff studied physics at Yale, got his PhD at Harvard, did his postdoc at MIT, and has been a professor at Princeton ever since. And Logiqal is just the beginning of where we see this going.
Here's what makes this moment so rare. There are only about 250 quantum startups globally. The talent pool at the frontier is extraordinarily small. We're talking about hundreds of people in the entire world. These are people who've gotten PhDs at the top research institutions globally. And yet the market opportunity is estimated at $850 billion by 2035. The moats being built right now are measured in physics breakthroughs and manufacturing know-how. If you're a founder building in quantum computing, quantum infrastructure, or quantum-enabled applications, we want to hear from you. The window to define this category is open right now, but it's narrowing fast.
As Lex and I said, we spent the last 2 years going deep in this incredible category, and we are so excited to continue learning more. If you're a founder out there building anything in this space, come talk to us. We're excited to hear from you.